3 o'clock in the morning, you wake up from a dream you cannot remember. For a moment hanging between sleep and being awake, a strange thought grabs you. Have I been here before? Not this room, not this night, but this exact moment. This exact pattern of shadows on the ceiling, this same beat of your heart, the feeling fades. You brush it off as nothing. But the question stays, what if a demon came to you tonight and whispered that you will live this life again and again forever? Every joy, every sorrow, every breath, would you curse that demon or thank him? Friedrich Nietzsche called this the heaviest weight ever placed on human shoulders. Albert Einstein proved that time itself can bend. And modern physics suggests that everything you live through might already exist, frozen forever in a four-dimensional block of spacetime. Could life repeat itself? The answer might scare you or set you free. Chapter 1. The question that haunts humanity. But before we begin, do not forget to subscribe. And if you truly enjoy these videos, please leave a like. Let us begin. 3 o'clock in the morning, you wake up from a dream. You cannot remember it. For a moment hanging between sleep and being awake, a strange thought grabs you. Have I been here before? Not this room, not this night, but this exact moment. This exact pattern of shadows on the ceiling, this same beat of your heart. The feeling fades. You brush it off as nothing, but the question stays. Could life repeat itself? It is maybe the oldest question people have ever asked. Long before we built telescopes to look into faraway galaxies. Long before we split atoms or mapped the human genome. Long before we even learned to write, our ancestors sat around fires and wondered. Does existence move in circles? Are we living a story that has already been told? This is not just daydreaming. This question sits where everything we know meets everything we badly want to understand. It touches physics. It touches consciousness. It touches the very fabric of what we call reality. And in the 21st century, for the first time in human history, science is starting to offer answers. Tonight, we will travel through time itself. We will walk beside the ancient philosophers who first said that existence moves in endless cycles. We will stand with Friedrich Nietzsche on a mountain in Switzerland, where he said he had received the most frightening idea ever imagined by the human mind. We will sit in the patent office with a young Albert Einstein who would soon prove that time is not what we think it is at all. We will travel to the edge of black holes where time slows to a crawl. We will watch astronauts age differently than their twins left behind on Earth. We will explore the wild math of wormholes and closed time-like curves, theoretical ideas that suggest physics itself does not forbid traveling backward through time. But we will also look inward. We will study the strange feeling of déjà vu, that eerie sense that you have lived this exact moment before. Neuroscientists have studied it. They have ideas, but the experience itself stays deeply mysterious. We will ask whether the universe could be cyclical. Not a one-time event that began with a bang and will end in darkness, but a breathing thing that expands and contracts, dies and is reborn again and again through eternity. The Big Bounce theory suggests exactly this. Some physicists believe we may be living in just one round of an infinite series, and we will face the block universe. This is the idea supported by Einstein's own equations that past, present, and future all exist at the same time. That your birth and your death are both happening right now, frozen in a four-dimensional block of spacetime, that the flow of time is an illusion, that everything that will ever happen has, in some way, already happened. These are not strange fringe ideas. They come from the most careful physics humanity has ever built. They appear in peer-reviewed journals and are argued about by Nobel Prize winners. They suggest that our everyday idea of time, of before and after, of cause and effect, may be deeply wrong. But maybe the most haunting possibility comes from philosophy itself. What if life does not just look like itself across the ages? What if it truly repeats? Every joy, every sorrow, every breath you have ever taken, every thought you have ever had. What if you have lived this exact life an infinite number of times before? What if you will live it an infinite number of times again? This is the idea of eternal recurrence. Nietzsche called it the heaviest weight imaginable. He asked whether you could accept such a fate, whether you could look at your life with all its pain and all its beauty and say, yes, I would live this again and again forever. The question is not only about theory. It changes how we think about meaning. It changes how we understand choice. If every decision you make has already been made infinite times and will be made infinite times again, does free will exist? If the future is as fixed as the past, what does it mean to hope? These questions can feel crushing. They can cause a kind of dizziness, like standing at the edge of a deep drop. But they can also be freeing. They push us to face what really matters. They strip away the small stuff and show what is essential. Throughout history, people have struggled with the idea that existence moves in circles. The ancient Hindus spoke of huge cosmic cycles called yugas, times of creation and destruction that repeat without end. Buddhists described samsara, the wheel of birth, death, and rebirth that holds all living beings. The ancient Greeks said the cosmos sometimes returns to its first state, that all events happen again in exactly the same order. These were not simple superstitions. They were smart attempts to make sense of patterns that seemed to show up everywhere. The seasons returning year after year, generations replacing each other in endless succession. The rise and fall of empires. The repeating of wars and plagues and revolutions. Something in the shape of reality seemed to suggest repetition. Modern science has mostly pushed aside these old cyclical cosmologies. The main view for most of the 20th century was that the universe had a clear beginning in the Big Bang and would have a clear end. Either in a heat death as energy spreads out, or in a big crunch as gravity pulls everything back together. Time was an arrow, not a wheel. History was a journey, not a cycle. But the 21st century has made this picture messier. New theories in physics suggest that the Big Bang may not have been the true beginning. That something came before, that our universe may be just one in an endless series, each born from the death of the one before. The arrow of time may bend, it may curve back on itself, the wheel may turn after all, and even if the cosmos does not truly repeat, there are other ways life could echo across the ages. Quantum mechanics suggests that identical particles are truly indistinguishable, that two electrons are not just alike, but truly the same. If the exact setup of matter and energy that makes you were to appear again somewhere, would that be you? Would you be living again? These questions blur the line between science and philosophy, between physics and metaphysics. They force us to think carefully about what we mean by identity, by continuity, by existence itself. They demand clear ideas even as they open up huge spaces of uncertainty. This is what we will explore tonight. Not to give easy answers, there are none, but to shine light on the question itself, to show why it matters, to show that the greatest minds in human history have fought with this problem and still fight with it. This journey will take us from ancient temples to modern laboratories, from the mystical visions of religious sages to the cold equations of theoretical physics, from the private experience of your own mind to the largest structures in the visible universe. Along the way, we will meet ideas that may unsettle you, ideas that may comfort you, ideas that will almost surely change how you think about your own life and your place in the cosmos. Because in the end, the question of whether life could repeat itself is really a question about meaning. If everything happens once and only once, that gives existence a certain weight, a certain preciousness. Each moment is one of a kind. Each choice cannot be undone. There are no second chances. But if everything repeats, the weight shifts, not always disappearing, but spreading out. If you will face this choice again, if you will live this moment again, what does that change? Does it make your choices more important or less? Does it make pain easier to handle or more awful? Does it make joy brighter or does it fade into endless repetition? Different thinkers have answered these questions in different ways. For some, the idea of eternal recurrence is the greatest yes to life. To say yes to one moment is to say yes to all of existence. To accept your fate fully with amor fati, with love of fate, is to reach a kind of rising above. For others, the thought is pure horror, a cosmic prison with no way out, an endless replay of all your mistakes, all your regrets, all your pain, not just once but forever. Not moving toward anything, but simply going around and around and around. We will not judge between these answers. Both can make sense. Both capture something true about being human. The question is not which reaction is right, but what the question itself shows about who we are and what we care about. So, let us begin this journey. Let us travel back through the thousands of years to the first civilizations that looked up at the turning stars and saw a cosmos that moved in cycles. Let us trace the growth of this idea through the great religious and philosophical traditions of humanity. Let us see how it changed when it met modern science. And let us ask what it might mean for us here now, in this exact moment that may or may not ever come again. The question haunts us. It has always haunted us. Perhaps it always will. Have you been here before? Are you here right now? Will you be here again? Let us find out together. Chapter 2. Ancient Wisdom and the Wheel of Time. 5,000 years ago, in the river valleys of the Indus, priests performed rituals that would echo through the ages. They looked at the world around them and saw a pattern. The sun rose and set. The moon grew and shrank. The seasons turned from spring to summer to autumn to winter and back again. Rivers flooded and pulled back. Generations were born, lived, died, and were replaced by new generations. Everything moved in circles. From this came one of humanity's oldest and most lasting ideas. The universe itself moves in cycles. Time is not a line stretching from a start to an end. It is a wheel turning endlessly, bringing all things back to where they began. This idea would shape the religions and philosophies of billions of people across thousands of years. It would lead to beliefs about reincarnation and karma, ideas that still guide the lives of more than a quarter of the world's population today. And it would pose a challenge that modern science is only now starting to face. The ancient Hindus developed maybe the most detailed cyclical picture of the universe in human history. They divided time into vast ages called yugas, periods of creation and destruction that last millions of years. The age they believed we are in is the Kali Yuga, a dark age of spiritual decline. It began around 5,000 years ago and will continue for hundreds of thousands of years more. But it too will end. And when it does, the cycle will begin again. Beyond the yugas are even bigger cycles. 1,000 cycles of 4 yugas make one day of Brahma, the creator god. And Brahma himself lives for 100 divine years, after which the whole cosmos melts back into formlessness, only to be made again once more. The numbers are huge. The times are bigger than anything in Western thought. But the idea is simple. Everything that begins must end, and everything that ends will begin again. This cosmic turning shows up at the personal level in the idea of samsara, the wheel of birth and rebirth. The Atman, the everlasting soul, does not die with the body. It moves from one life to another, living in different forms, experiencing different fates. A king may be reborn as a beggar. A human may be reborn as an animal. The soul travels through countless lives, collecting karma, the spiritual leftovers of its actions. Karma is the link that ties one life to the next. Good actions in this life lead to better conditions in the next. Bad actions lead to suffering. The cosmos is perfectly fair even if that fairness plays out across many lifetimes. Nothing is random. Everything comes from earlier deeds. But samsara is not seen as a gift. It is a trap, the goal of Hindu spiritual. Practice is moksha, freedom from the cycle, to step off the wheel of rebirth. To understand that the individual soul and the universal soul are one. To melt back into the infinite and be free from the endless turning. Buddhism, which grew from the Hindu tradition around 250 years ago, kept the idea of cyclical rebirth, but changed its meaning. The Buddha rejected the idea of an eternal, unchanging soul. What moves from life to life is not a fixed self, but a stream of consciousness, a flowing chain of mental events, like one candle lighting another. The Buddha described 6 realms of existence through which beings cycle. The realm of the gods who live in pleasure but are not enlightened. The realm of the demigods filled with jealousy and conflict. The realm of humans where suffering and happiness are mixed and where enlightenment is possible. The realm of animals driven by instinct and fear. The realm of hungry ghosts tormented by endless desires. And the realm of hell beings suffering unthinkable pain. These realms are not fixed places. They are states of mind, ways of being that arise because of karma. A single being might pass through all of them, rising and falling based on its actions. The wheel turns and beings rise and fall with it. The Buddhist goal, like the Hindu goal, is to step off the wheel. Nirvana is the ending of craving, the end of the cycle of rebirth. It is not being erased, but freedom, the stopping of suffering, the waking up from the dream of separate existence. Jainism, another tradition that grew in ancient India, built its own version of the cyclical worldview. The Jains believed that the universe moves through rising and falling half-cycles, times of moral improvement followed by times of moral decline. Right now, we are in a falling half-cycle. Things will get worse before they get better, but eventually the cycle will turn and a new golden age will come. For the Jains, the soul, called the jiva, is weighed down by karma, which they pictured as a kind of subtle matter that sticks to the spiritual substance. The goal of Jain practice is to stop new karma from building up through strict ethical living and to burn off the karma already collected through ascetic practices. When all karma is gone, the soul rises to the top of the universe and reaches liberation. These Indian traditions were not alone in thinking of time as cyclical. On the other side of the world in ancient Greece, philosophers were building similar ideas. The Pythagoreans, followers of the mystical mathematician Pythagoras, taught that souls move from body to body, growing toward purity through a series of lives. Pythagoras himself claimed to remember his past lives. Plato, the greatest Greek philosopher, placed reincarnation into his philosophical system. In dialogues like the Phaedo and the Republic, he argued that the soul is immortal and passes through many lives. Before birth, souls exist in a realm of pure forms where they think about eternal truths. When they are born into bodies, they forget what they knew. Learning is therefore a process of remembering, of getting back the knowledge the soul had before it entered the body. The Stoics, a later school of Greek philosophy, developed a doctrine of cosmic recurrence. They believed the universe sometimes goes through a great conflagration, returning to pure fire. From this fire, a new cosmos is born, exactly the same as the one before. Every event repeats in the same order. Every person who has ever lived will live again, making the same choices, feeling the same joys and sorrows. This is eternal recurrence in its most literal form. Not just repeating similar patterns and events, but repeating these exact individuals, these exact moments. The universe is an endless loop, replaying the same movie again and again and again. The ancient Egyptians thought about time differently, but still in a cycle. The daily journey of the sun god Ra through the sky and through the underworld showed the endless struggle between order and chaos, light and darkness. Each morning was the world being made again. Each night was a trip through death, and each dawn was a return to life. The Egyptians focused on cyclical renewal. Their complex burial practices were meant to make sure that the dead would be reborn, that the cycle would continue. The scarab beetle, which rolls balls of dung and lays its eggs inside, became a sign of rebirth, of the sun rolling across the sky, of life coming from death. In Mesoamerica, the Maya built one of the most advanced systems of cyclical time ever created. They used several interlocking calendars, each tracking different cycles of days, months, years, and longer periods. The long count calendar marked the end of a great cycle in December 2012, leading to lots of wrong guesses about the end of the world. But for the Maya, the end of a cycle was not the end of time. It was the start of a new cycle, a return to the beginning. The Norse people of Scandinavia believed in Ragnarok, a final battle where the gods would die and the world would be covered by fire and flood. But from that destruction, a new world would rise, green and fertile. 2 human survivors would fill the earth again. The cycle would begin again. What should we think about this surprising match? Cultures separated by great distances and thousands of years with no contact still formed the idea that time moves in cycles, that existence repeats, that death is not the end but a doorway to another state. One reason is simple watching. The cycles of nature are clear to anyone who looks. The sun rising and setting, the moon changing shape, the turning of the seasons, the rhythm of birth and death. It would be strange if ancient people did not see these patterns and extend them. But maybe the pull of cyclical time is deeper. Maybe it answers a basic human need. The straight-line idea of time, with its final beginning and final end, is frightening. It means everything disappears forever. It means death is final. It means the cosmos itself has an end date. Cyclical time offers a kind of comfort. Nothing is ever fully lost. Everything comes back around. The dead are reborn. The past returns. The future already shows up in the patterns of the present. There is no true newness, but also no true destruction. This can feel comforting or terrifying depending on how you see it. If your life is good, the thought of living it again and again might feel nice. If your life is painful, the thought of endless repeating is a nightmare. Ancient traditions often noticed this mixed feeling. They offered the chance to escape, to be free from the wheel, for those who found the cycle unbearable. Modern science, as we will see, has mostly replaced the cyclical view with a straight one. The universe began in the Big Bang and will end in heat death or collapse. Time is an arrow, not a wheel. Events happen once and are gone forever. But as we will also see, this straight picture is being challenged. New ideas in cosmology suggest that the Big Bang may not have been the true beginning, that something came before, that the universe may be cyclical after all, though in ways far more complex than the ancients imagined. And even inside the straight-line picture, the question of recurrence remains. If the universe is infinite in space or time, if identical setups of matter can appear more than once, if the laws of physics allow closed loops through time, then the ancient feeling may turn out to be right. Life may repeat not because time is a wheel, but because infinity is strange, because the possible arrangements of matter are limited while spacetime may be limitless. Because given enough time, everything that can happen will happen again. The ancients saw something real. They sensed a pattern in reality that modern science is only now starting to understand. The wheel of time may turn after all. The question is what this means for us here now in this particular turning. But before we can answer that, we must meet the philosopher who turned the ancient idea of eternal recurrence into a modern challenge. A man who walked alone in the Swiss mountains and received what he called the most terrifying thought ever imagined. A man named Friedrich Nietzsche. His vision would haunt the 20th century. It haunts us still. Chapter 3, The Philosopher Who Dared to Repeat Forever. August 1881, the Swiss Alps. A man walks alone along the shores of Lake Silvaplana near the small town of Sils Maria. He is 36 years old, though he looks older. His health is failing. Severe migraines torment him. His eyesight is getting so bad that he can barely read or write. He has resigned from his job at the University of Basel. He has no permanent home. Moving from boarding house to boarding house across Europe, he is almost unknown. His books sell almost nothing. His name is Friedrich Nietzsche. And on this day, walking past a massive, pyramid-shaped rock at the edge of the lake, a thought hits him with such force that he will later describe it as a revelation. He starts to cry, not from sadness, but from the crushing weight of what he has imagined, the eternal return. Nietzsche will call this idea the heaviest weight imaginable, the most terrifying thought ever formed by the human mind, and yet also maybe the most freeing. It will become the center of his philosophy, the test by which all values are measured. What is this idea that struck him so strongly? Imagine, Nietzsche says, that a demon comes to you in your loneliest hour and speaks. This life as you now live it and have lived it, you will have to live once more and countless times more, and there will be nothing new in it. Every pain and every joy and every thought and sigh and everything unbelievably small or great in your life will come back to you, all in the same order and sequence. Even this spider and this moonlight between the trees, even this moment and I myself, the eternal hourglass of existence is turned upside down again and again, and you with it, speck of dust. How would you react to such a message? Would you throw yourself down and gnash your teeth and curse the demon who spoke? Or would you have a tremendous moment, a moment when you answered, "You are a god and never have I heard anything more divine"? This is the question Nietzsche asks. This is the test. To understand why this idea hit Nietzsche so hard, we must understand the crisis in thinking he was answering. Nietzsche was the philosopher who said God is dead. By this, he did not mean only that religious belief was shrinking, though it was. He meant that the whole deep framework that had given Western civilization its meaning was breaking apart. For nearly 2,000 years, Christianity had given Europeans a story about existence. The universe was created by a loving God. Human life had a purpose, to know and serve this God. Morality was based on divine commands. Death was not the end, but a step into eternal life. History was moving toward a final fulfillment, a kingdom of heaven where all suffering would be made right. This story was falling apart. Darwin had shown that humans were not special creations, but the result of blind evolution. Science was showing a universe that did not care about human hopes. Biblical criticism was weakening the authority of Scripture. Modern life was melting the old certainties that had made life feel meaningful. Nietzsche saw this clearly, and he asked a question that few people around him dared to face. If God is dead, if the old values no longer work, what comes next? How do we make meaning in a universe that does not hand us any? Many of Nietzsche's peers answered with what he called nihilism. If there is no God, if there is no higher meaning, then nothing matters. All values are made up. Life is pointless. We might as well give up. Nietzsche hated this answer. He saw it as weakness, as a lack of courage and creativity. The death of God was not a tragedy. It was a chance. For the first time in human history, we could create our own values. We could become, as he said, the overman, the being who rises beyond the old morality and makes new values from the deepest part of itself. But how could we know if the values we make are real? How could we tell true creation from mere reaction, from bitter rejection of what came before? This is where the eternal return matters. It is a test for values. It is a way of measuring whether you truly say yes to your life or only tolerate it. Think about the question again. If you had to live your life over and over exactly as it is, would you accept that fate? Would you say yes to every moment, even the moments of pain, even the failures and the losses and the hurt? If you would not, then you do not truly say yes to your life. You are living in bad faith. You are hoping for something else, something better, something that will fix the present. You are not accepting existence as it is. But if you could say yes, if you could welcome the eternal return with joy, then you have reached what Nietzsche calls amor fati, love of fate. You have accepted existence as a whole. You have stopped wishing things were different and started wanting things to be exactly as they are. This is not weak acceptance. It is not giving up. It is an active embrace. To love your fate is not to surrender to it, but to affirm it, to choose it, to want it to be exactly what it is. Nietzsche shows this through the figure of Zarathustra, the hero of his great philosophical novel, Thus Spoke Zarathustra. Zarathustra is a prophet who comes down from the mountains to teach people about the overman. But the most important lesson he must learn himself is the eternal return. In one of the book's strongest scenes, Zarathustra is climbing a mountain path when he meets a dwarf sitting on his shoulders, whispering heavy thoughts in his ear. This dwarf stands for the spirit of gravity, the heavy pulling force that drags us into nihilism and despair. Zarathustra dares the dwarf to think about the gateway in front of them. The gateway is called moment. Two paths run from it. One path stretching into the past runs backward forever. The other path stretching into the future runs forward forever. These two paths seem to oppose each other. They meet at this gateway at this moment. But Zarathustra asks a question. What if these paths do not oppose each other? What if they are the same path? What if whoever follows the path into the future eventually comes back to this gateway, having traveled in a circle through eternity? The dwarf answers lightly, time itself is a circle, of course everything returns. But Zarathustra scolds him. This is too easy. The dwarf has not truly understood the weight of the idea. He has not felt it inside himself. To truly understand the eternal return is not just to think that events might repeat. It is to feel the full meaning of that repeating. It is to see that this moment, this gateway, this choice you are making right now is eternal. It has happened infinite times before. It will happen infinite times again. It is not a passing second, but a permanent fact of existence. The weight of this is huge. It changes how you think about everything. Every small grudge, every little cruelty, every moment of cowardice, you will have to live these again and again forever. But also every moment of beauty, every act of love, every instant of real happiness, these too are eternal. Scholars of Nietzsche have argued for over a century about what he meant by the eternal return. Did he believe it was literally true? Did he think the universe really repeats itself in an endless cycle? Or was it only a thought experiment, a what-if meant to test how we live? Some evidence suggests Nietzsche took the idea seriously as a scientific guess. In his notebooks from that time, he explored scientific arguments for eternal recurrence. If the universe has a limited amount of energy and endless time, he reasoned, then every possible arrangement of energy must come back an endless number of times. The math seems to support the idea. Modern physics has complicated this picture. We now know the universe is expanding and that it began in a special state about 13.8 billion years ago. The simple model of eternal recurrence that Nietzsche sketched does not fit what we now think about cosmology. But that may not matter. The power of the eternal return is not in whether it is scientifically true, but in how it hits the human mind. As a thought experiment, it stays as strong as ever. The question it asks never gets old. Could you love your life so completely that you would want to live it again, unchanged, forever? This is what Nietzsche meant when he called the eternal return the greatest weight. It is a burden that either crushes you or makes you stronger. If you cannot carry it, if you would curse the demon who told you, then you have not yet learned to say yes to life. If you can welcome it, if you can say yes to the eternal hourglass, then you have reached something rare. You have become a yes-sayer. You have beaten nihilism not by finding new gods, but by learning to love fate itself. The influence of this idea has been huge. Existentialist philosophers like Albert Camus and Jean-Paul Sartre wrestled with it all their lives. The myth of Sisyphus, forced to roll a boulder up a hill forever only to watch it roll back down, becomes bearable, even joyful, when seen through the lens of eternal return. We must imagine Sisyphus happy. Camus wrote, "Psychologists have noticed the healing power of the idea. If you cannot accept your past, if you always wish you had chosen differently, you will never feel peace. The eternal return forces you to make peace with what is, to stop living in regret and start living in affirmation. But the idea also has a darker side. If everything repeats, if the future is as fixed as the past, what room is there for real change? What does it mean to struggle, to fight, to work for a better world if everything is already decided? If the suffering you see today will return forever, is it not easier to look away? Nietzsche himself struggled with these problems. In his later work, he more and more stressed the creative power of the overman, the ability to place new meaning onto existence through sheer will. But the tension between eternal recurrence and creative freedom was never fully solved. Perhaps it cannot be solved. Perhaps the eternal return stays what Nietzsche meant it to be. Not an answer, but a question each of us must face in our own way. A question that shows what we truly value and who we truly are. The philosopher walking by the lake in 1881 did not know that within 10 years his mind would break, that he would spend his last years in madness and silence. He did not know that his ideas would be stolen by the Nazis, twisted into support for horrors he would have hated. He did not know that a century later scholars would still argue about what he truly meant. But in that moment by the lake, something was shown to him, a truth or a challenge or a question that has lost none of its power. The eternal return still faces us. Would you live your life again? Would you live it exactly as it is? Would you say yes? The question waits for your answer, and according to Nietzsche, you have already answered it an infinite number of times before. Chapter 4. Einstein and the Bending of Time, 1905, a patent office in Bern, Switzerland. A young man sits at his desk, supposed to be checking applications for new inventions. But his mind is far away. He is thinking about light, about motion, about something that has confused physicists for decades. His name is Albert Einstein. He is 26 years old. He has not been able to get an academic job. His PhD thesis was first rejected. To support himself and his young family, he has taken this government job judging patent applications for electromagnetic devices. And yet, in his free time, in hours stolen from his official work, he is about to overturn our understanding of the universe. The problem that obsessed Einstein was strangely simple. Light travels at a constant speed, about 300,000 km/s. This had been shown by experiments, but constant compared to what? If you are moving toward a light source, should you not measure the light as moving faster? If you are moving away, should it not seem slower? Old physics said yes. The speed of light should add to or subtract from the speed of the observer, like the speed of a ball thrown on a moving train, which depends on whether you are on the train or standing on the platform. But experiments showed something else. The speed of light was the same for all observers, no matter how they moved. It did not add or subtract. It stayed stubbornly constant. This was impossible, or at least it was impossible if you kept certain beliefs that seemed clearly true. Beliefs like space being the same everywhere and time flowing at the same speed for everyone. Beliefs that had been the base of physics since Newton. Einstein did something bold. He kept the constant speed of light and threw away the beliefs. He asked, what if space and time are not what we think they are? What if they bend and stretch depending on how fast you move? The result was the special theory of relativity. And one of its most shocking results was time dilation. Time dilation is exactly what it sounds like. Time stretches. Clocks tick at different speeds depending on how they move. A clock moving compared to you will tick more slowly than a clock staying still compared to you. The faster it moves, the slower it ticks. At the speed of light, time would stop completely. This is not a figure of speech. It is not a trick of the eyes. It is a real physical effect proven by many experiments. Atomic clocks flown around Earth on airplanes tick more slowly than matching clocks left on the ground. The difference is tiny, only a few billionths of a second, but it is measurable, and it matches Einstein's predictions exactly. Particle accelerators give even stronger proof. Subatomic particles called muons are made high in the atmosphere when cosmic rays hit air molecules. Muons are unstable. They fall apart after about 2 millionths of a second. At this rate, they should only move a few hundred meters before they break apart. They should never reach the ground. But they do reach the ground by the thousands because they move close to the speed of light and their inner clocks run slowly. From our view on the ground, they live much longer than 2 millionths of a second. Their time is dilated. What does this have to do with whether life could repeat itself? Everything. Time dilation shows that time is not absolute. It is not a fixed stage where events happen. It is part of the fabric of reality, woven together with space into one thing called spacetime. and spacetime can be bent, stretched, and warped by motion and gravity. This means the common-sense idea of time, the belief that there is one universal, now, across the universe, the belief that past and future are completely different from the present, is wrong, or at least deeply incomplete. Think about the famous thought experiment called the twin paradox. Two identical twins live on Earth. One stays home, the other rides a spaceship and travels close to the speed of light to a faraway star, then turns around and comes back. When the traveling twin returns, she finds something amazing. She has aged only a few years, but her twin has aged decades. They are no longer the same age. Time moved differently for them. This is not science fiction. This is proven physics. We have tested it. We know it is true. In 1971, physicists Joseph Haefel and Richard Keating put atomic clocks on commercial planes and flew them around the world. When compared to clocks that stayed on the ground, the flying clocks had lost a few billionths of a second. Time dilation happened exactly as Einstein said it would. In 2015, NASA astronaut Scott Kelly spent almost a year on the International Space Station, orbiting Earth at about 28,000 km/h. His identical twin brother, Mark, stayed on Earth. When Scott returned, he had aged about 5 milliseconds less than Mark. 5 milliseconds is tiny, you would never notice it, but the rule is what matters. Time flows differently for different observers. Your experience of how long things last depends on how you move through space. Now scale this up. Imagine spaceships that can travel at 90% of the speed of light. At that speed, the time dilation factor is about 2.3. A trip that takes 10 years from Earth's point of view would feel like only about 4 years to the traveler. She would return and find that her friends had aged more than twice as fast as she had. Push faster to 99% of the speed of light, and the factor jumps to about 7. A 7-year trip for the traveler matches nearly 50 years on Earth. She could return to find her grandchildren older than she is. At 99.9% of the speed of light, the factor is about 22. At 99.99%, it is over 70. In theory, if you could travel close enough to light speed, you could cross the whole visible universe while aging only a few years. Billions of years would pass on Earth. Your species would probably be gone, but you would still be alive, having skipped over time like a stone skipping on water. This is a kind of time travel, not into the past, future, but into. By moving very fast, you can effectively fast forward through time compared to people who stay behind. You can visit the future and see what happens to humanity, what happens to the stars, how the story ends. But there is a catch. You cannot come back, at least not with speed-based time dilation. You can only go forward. The past seems out of reach. Or is it? In 1915, Einstein finished his general theory of relativity, which extended his earlier work to include gravity. General relativity describes gravity not as a pull like Newton thought, but as a curving of spacetime caused by mass and energy. Planets orbit stars not because they are pulled by hidden forces, but because they follow the straightest possible paths through curved spacetime. And general relativity made a prediction even more surprising than special relativity. Time dilation happens not only from speed, but also from gravity. The stronger the gravity, the slower time passes. This too has been proven. Clocks higher up run a little faster than clocks at sea level because they are farther from Earth's gravity center. GPS satellites orbiting Earth must account for this effect. Without fixes for gravitational time dilation, your phone's navigation would be off by kilometers. Near extreme gravity sources like black holes, the effect becomes huge. At the event horizon of a black hole, the line beyond which nothing can escape, time from the outside view stops completely. An astronaut falling into a black hole would, from our view, freeze at the horizon, never quite going in, her image growing dimmer and redder as light struggles to escape. From her own view, though, she would cross the horizon in a limited time and keep falling toward the singularity at the center. Time feels wildly different for different observers. In the movie Interstellar, astronauts visit a planet so close to a massive black hole that 1 hour on the surface equals 7 years on Earth. When they return to their ship, their friend who waited in orbit has aged 23 years while they felt only a few hours. This is not fantasy. It is what the equations of general relativity predict. We have not tested it at such extreme levels because we cannot visit black holes yet. But there is no clear reason to think the equations would break. They have matched every test we can do. General relativity opens even stranger possibilities. Some solutions to Einstein's equations contain what are called closed time-like curves, paths through spacetime that loop back on themselves. Something traveling along such a path would return to its own past. It would truly travel backward in time. This sounds like pure science fiction, and for decades, physicists dismissed it as math with no real meaning. The solutions with closed, time-like curves, like the Gödel metric found by logician Kurt Gödel in 1949, seem to require impossible conditions, like a universe that rotates as a whole. But in the 1980s and 1990s, physicists began to take the idea more seriously. Thinkers like Kip Thorne showed that wormholes, hypothetical tunnels through spacetime, could in principle be used to build time machines. The physics was uncertain but not clearly impossible. We will explore these strange possibilities in the next chapter. For now, the main point is this. Einstein's theories smashed our common-sense picture of time. They showed that time is not a fixed river flowing at the same speed from past to future. It is part of the flexible, changing fabric of spacetime. It can stretch and squeeze. It can bend and curve. Different observers can experience it differently. This has deep meaning for whether life could repeat itself. If time is not absolute, if past and future are not as separate as we feel they are, then the meaning of repeating becomes unclear. What does it mean for an event to happen twice, if there is no universal time where both happenings can be placed? Even more, some readings of relativity suggest that the past, present, and future all exist at once. This is the block universe, which we will explore later. If the block universe is right, then everything that will ever happen has, in some way, already happened. The future is as fixed as the past. Time does not flow, it simply exists. In such a universe, what would it mean for life to repeat? Maybe repeating is the wrong idea. Maybe what exists is one eternal pattern, a four-dimensional sculpture in spacetime, holding all your births and all your deaths, all your joys and all of your sorrows, frozen together in a timeless whole. Einstein himself was drawn to this view. After the death of his close friend Michel Besso, Einstein wrote a letter to Besso's family. "Now he has left this strange world a little ahead of me." Einstein said that means nothing. For those of us who believe in physics, the difference between past, present, and future is only a stubbornly persistent illusion. This is a remarkable line from the greatest physicist of the 20th century. Time as an illusion, past and future as equally real, death as only a move to another part of the block. Did Einstein believe in eternal recurrence? Not in Nietzsche's sense. But his physics opened doors the old philosophers could never have dreamed of. It showed that time is stranger than we ever guessed. That the universe may not be a story unfolding, but a pattern already complete. That everything that happens happens forever. The young man in the patent office thinking about light and motion could not have known where his ideas would go. He could not have foreseen quantum mechanics or black holes or the cosmic microwave background radiation. He could not have imagined the tools that would come from his theories, from nuclear power to GPS to laser surgery. But in that small office in Bern, he saw something basic about reality. Time is not what it looks like. And that changed everything. We are still learning what it means. The journey has only begun. Chapter 5. Traveling to tomorrow and yesterday. In 1988, physicist Kip Thorne received an unusual phone call. His friend Carl Sagan was writing a novel, a story about first contact with an alien civilization. Sagan needed a scientifically believable way for his main character to travel across the galaxy quickly. Faster-than-light travel seemed impossible. But maybe, Sagan wondered, there was another way. Thorne, one of the world's top experts on general relativity, thought about it. What if space itself could be folded? What if you could take a shortcut, not through space, but through the fabric of spacetime itself? The answer was wormholes. And the research Thorne did for a science fiction novel would open one of the most fascinating areas of theoretical physics, the physics of time travel. A wormhole is a hypothetical tunnel through spacetime. Picture the universe like a flat sheet of paper. 2 points on that sheet may be far apart if you measure along the surface. But if you fold the paper so the 2 points touch, you can poke through and make a shortcut. A wormhole is that shortcut. It connects far regions of spacetime without making you cross the space between. Wormholes show up naturally in the math of general relativity. Einstein himself, along with physicist Nathan Rosen, found a kind of wormhole in 1935, now called an Einstein-Rosen bridge. But those early wormholes were not passable. They would collapse instantly before anything could go through. They were math curiosities, not real travel devices. Thorne and his colleagues showed that under certain conditions, a wormhole could be kept open. It would need exotic matter, matter with negative energy density, to hold the throat of the wormhole open and stop it from collapsing. Such matter breaks the usual energy rules of physics, but it is not fully forbidden. Quantum mechanics allows small amounts of negative energy in certain cases. Whether a large wormhole could really exist in our universe is still unknown. We have never seen one. The engineering problems of making and stabilizing one are beyond anything we can currently imagine. But the physics does not rule it out. In principle, wormholes are possible, and here is where things become truly strange. Thorne and his teammates realized that a wormhole could be turned into a time machine. The trick uses time dilation. Suppose you have a wormhole with two mouths linked by a short tunnel through spacetime. One mouth is here on Earth. The other is in a spaceship. You speed the spaceship up close to the speed of light and then bring it back. Because of special relativity time dilation, less time passes for the mouth that traveled than for the mouth that stayed on Earth. Suppose the trip takes 10 years as measured on Earth, but only 1 year for the traveling mouth. When the spaceship returns, the two mouths are still connected, but they now sit at different times. Step into one mouth and you come out the other, but in the past. 10 years in the past. In this example, you have traveled backward through time. This is not just science fiction guessing. It is what the equations of general relativity predict. Thorne's calculations were published in peer-reviewed physics journals. They have been checked and rechecked by experts worldwide. If wormholes can exist, and if they can be stabilized, then time machines are possible. The results are mind-blowing. If you could travel to the past, you could change it. You could prevent your own birth. You could kill your grandfather before your parent was conceived. This is the famous grandfather paradox, the logical clash at the heart of backward time travel. Physicists have suggested different ways to solve the paradox. The Novikov self-consistency principle, named after Russian physicist Igor Novikov, suggests that any time travel that would create a paradox is simply impossible. If you travel to the past, events will always stop you from changing anything that would make a contradiction. The gun will jam. The car will break down. Something will always get in the way. This can sound forced, but it may be how the universe works. The equations of physics can be deterministic. Given the starting conditions, everything that follows is fixed. If time travel happened, the loops would already be part of the solution. There would be no paradoxes because paradoxes cannot occur. What happens is what happens. Another idea uses parallel universes. Maybe traveling to the past does not send you to your own past, but to a different branch of reality, an alternate timeline where you can do anything without changing your original history. This idea is popular in stories and is supported by some readings of quantum mechanics, though it is still very speculative. Stephen Hawking, one of the most famous physicists of the late 20th century, doubted time travel. He proposed what he called the chronology protection conjecture, the idea that the laws of physics somehow prevent closed time-like curves from forming. Nature, Hawking suggested, works against time machines. Hawking's conjecture remains unproven. Some calculations suggest that quantum effects near a forming time machine would build up without limit, destroying the machine before it could be used. But other calculations suggest ways around those problems. The question is not settled. What is settled is that general relativity, our best current theory of gravity and spacetime, allows closed time-like curves. The theory does not forbid time travel. It makes room for it. Let us look at some specific solutions to Einstein's equations that allow travel to the past. The first was found by Willem Jacob van Stockham in 1937. He imagined an infinitely long cylinder of dust spinning quickly around its axis. Objects near such a cylinder would be dragged along by the spinning of spacetime itself, a phenomenon called frame dragging. Van Stockham showed that near a fast enough spinning cylinder, closed, time-like curves could exist. Something traveling the right way around the cylinder could return to its own past. An infinitely long cylinder is not physically realistic, but the solution showed that Einstein's equations did not ban time travel in principle. In 1949, Kurt Gödel found a solution that described a rotating universe. If the whole cosmos rotates, closed time-like curves exist for every observer. Every place in space would allow travel to the past just by following the right path through the rotating spacetime. Our universe does not seem to rotate. Observations of the cosmic microwave background radiation show no sign of overall rotation. But Gödel's solution was another proof of concept, another sign that the math of general relativity allows the seemingly impossible. In 1974, physicist Frank Tipler returned to Van Stockham's rotating cylinder. He showed that if such a cylinder were dense enough and spinning fast enough, it would create closed, time-like curves even if it were finite in length. A massive, fast-spinning rod could act like a time machine. Building such a thing would be wildly impractical. The mass would need to be like the mass of stars. The spin rate would approach the speed of light. The engineering problems are beyond imagining, but the physics does not forbid it. Wormholes, as we said, offer another path to time travel. By using the time dilation between the mouths, a wormhole can be turned into a path to the past. This is perhaps the most physically plausible. There is a time machine idea that has been suggested, but it needs exotic matter that may or may not exist. In 2010, physicist Ronald Mallet suggested a different way. He showed that a beam of light going around and around could, in principle, drag spacetime around with it, creating a time machine. The technology needed is far beyond what we can do today. But Mallet has spent his career exploring the idea. What would it mean if time travel were possible? What would it mean for the question of whether life could repeat itself? Think about this. If closed time-like curves exist, then cause and effect become loops. Something in the future can cause something in the past. The past and future are not separate places but intertwined, each affecting the other. The straight flow of time from past to future is shown to be a local illusion, not a basic rule of reality. In such a universe, the idea of repetition changes. It is not that events happen and then happen again later in order. It is that events are part of one self-consistent pattern, a loop with no beginning and no end. The loop does not repeat, it simply is. Imagine you travel back in time and meet yourself. You shake hands, you talk. Then you return to the present. What happened? The meeting did not repeat, it happened once. But it was part of a loop, a shape in space-time that connects your future to your past. These loops are strange. They go against what we feel should be true about how the world works. But they are not logically impossible. They are allowed by our best physics theories, and they suggest that time may be far more interesting than we ever imagined. Here is another idea. If the universe is infinite in space or time, and if the laws of physics are the same everywhere, then every possible arrangement of matter will happen an infinite number of times. Not because events repeat, but because there are endlessly many copies of every possible arrangement spread throughout the cosmos. This is not recurrence in the way Nietzsche imagined. It is parallel existence. There may be another version of you in a distant galaxy or in a far future era, living a life identical to yours. Not a repetition, but a duplication. Not one life lived many times, but many identical lives lived once each. Is this comforting or disturbing? Does it matter if another you exists somewhere in the infinite expanse? Does that other you share your identity? Are you somehow the same person? These questions push us to the limits of what physics can answer. They force us to be clear about what we mean by identity, by continuity, by self. They demand careful philosophy even though they come from scientific ideas. One thing is clear. The simple picture of time, common sense past becoming present becoming future, is wrong. Time is richer, stranger, more flexible than we ever guessed. Einstein showed us this. His successors have explored what it means, and the journey is not over. We still do not know if wormholes exist, if closed, time-like curves can really happen in nature, if time machines can be built. But we do know that physics does not forbid these things. We know our theories allow possibilities that feel like magic. We know that reality does not have to match our instincts. The question of whether life could repeat itself is partly a question about the structure of space-time. And that structure, as far as we can tell, allows far more than our ancestors ever dreamed. Somewhere, perhaps, a wormhole is waiting. A path through the fabric of reality, linking past to future, future to past. A loop in time, eternal and unchanging. Whether we will ever find it is another matter. Whether we should want to find it is another still. But the possibility exists. The equations allow it. The universe may be stranger than we can imagine, and we are only beginning to understand. Chapter 6. The universe that breathes. 13.8 billion years ago, everything began. All the matter and energy in the observable universe, everything that would become galaxies and stars and planets and people, was squeezed into a state of unimaginable density and heat, and then it exploded outward. This is the Big Bang, the standard model of cosmology, the creation story of modern science. For most of the 20th century, it seemed final. The universe had a beginning. Before that beginning, there was nothing. Not empty space, not darkness, nothing at all. But in the 21st century, this picture is being challenged. New theories suggest the Big Bang may not have been the absolute beginning. Something may have come before. Our universe may be just one phase in an eternal cycle of expansion and contraction. The cosmos may breathe, expanding and contracting like a cosmic lung, dying and being reborn over and over forever. This is the Big Bounce, and it may be the most powerful scientific support ever proposed for the ancient idea that time is cyclical. The idea that the universe could be cyclical is not new. As we have seen, ancient cultures around the world pictured time as moving in great circles. Hindu cosmology spoke of vast cycles lasting billions of years. The Stoics believed the cosmos sometimes returned to pure fire and then was reborn. Even Albert Einstein briefly considered an oscillating universe in the 1930s. But for decades, cyclical cosmology was considered scientifically dead. The discovery that the universe is expanding, along with the laws of thermodynamics, seemed to rule out endless cycles. The problem is entropy. The second law of thermodynamics says that in any closed system, entropy, roughly the amount of disorder, always increases. Each cycle of the universe would have more entropy than the one before. The cycles would grow longer and larger. Going backward, they would get shorter and smaller, heading toward a single beginning. A first cycle, a real creation. This argument seemed airtight. If entropy always increases, the universe cannot be truly cyclical. There must have been a beginning, but cosmologists are clever. They found ways around the entropy problem. New versions of cyclical cosmology do not need entropy to go down. Instead, they suggest ways entropy can be reset or spread out, allowing for true eternal recurrence. The most well-known of these theories is the ekpyrotic model developed by physicist Paul Steinhardt and his collaborators in the early 2000s. The name comes from the ancient Stoic idea of ekpyrosis, the periodic conflagration that consumes the world. In the ekpyrotic model, our universe is a three-dimensional membrane or brain floating in a higher dimensional space. Parallel to our brain is another brain, separated by a tiny gap. From time to time, these brains collide. The collision releases enormous energy, creating the hot, dense conditions we connect with the Big Bang. But it is not a beginning from nothing. It is a change from an earlier state. After the collision, the brains separate and our universe expands. It goes through all the stages. We see atoms form, stars ignite, life evolve. Eventually, expansion slows and reverses. The brains move toward each other again. They collide. A new Big Bang happens. A new cycle begins. The key new idea in the ekpyrotic model is that each cycle includes a time of slow contraction before the bounce. During this contraction, the universe becomes smoother. Uneven parts are erased. The entropy problem is solved not by lowering entropy, but by thinning it out, spreading it across an ever larger volume, so each new cycle begins in a condition that can form structure. This is cyclical cosmology for the 21st century. It keeps what the Big Bang model explains while placing it inside a bigger picture. The Big Bang is real, but it is not the beginning. It is a repeating event happening again and again forever. Another approach to cyclical cosmology comes from loop quantum gravity, an attempt to join general relativity with quantum mechanics. In loop quantum cosmology, the singularity at the center of the Big Bang is removed. Instead of a point of infinite density where physics breaks, there is a bounce. The universe shrinks to a smallest size and then rebounds, moving smoothly from contraction to expansion. In 2006, physicist Abhay Ashtekar and his collaborators showed that loop quantum gravity naturally creates a bounce. When matter is squeezed to extreme density, quantum effects create a pushing force that prevents total collapse. The universe bounces back before reaching zero size. This matters a lot. If the Big Bang was a bounce from an earlier contraction, then something existed before. Our universe has a history stretching backward beyond what we can see. And if it bounced once, it may bounce again. The universe may be eternal, cycling through expansion and contraction with no beginning and no end. Physicist Roger Penrose has proposed another cyclical model, which he calls conformal cyclic cosmology. In this picture, each cycle, or eon, begins with a Big Bang and ends when all matter has decayed, and the universe is made only of radiation. At that point, with no massive particles left, the ideas of time and distance lose meaning. The infinitely large, cold end of one eon becomes indistinguishable from the infinitely small, hot beginning of the next. The end of one universe is the beginning of the next universe. Infinity equals zero. The cosmic snake eats its tail. Penrose has even said he found hints of his theory in the cosmic microwave background radiation, the afterglow of the Big Bang. He argues that certain circular patterns in the radiation could be the marks of colliding black holes from a previous eon, their gravitational waves stamped on our sky as echoes from before time began. These claims are still debated. Other scientists dispute Penrose's analysis. The patterns he points to may be chance statistics rather than real signals from a previous universe. The evidence is not final, but the theoretical framework is solid. Conformal cyclic cosmology is a mathematically consistent model of an eternal, cyclical universe. It may be wrong, but it cannot be ignored. What would it mean if the universe truly breathes? What would it mean if the Big Bang was not a beginning but a phase change, one of endlessly many across cosmic history? First, it would support the ancient feeling that existence moves in cycles. The Hindu yugas, the Stoic conflagrations, the Buddhist wheel of becoming. These would not be only poetic pictures, but real insights into reality. Our ancestors, without telescopes or particle accelerators, grasped something true about the cosmos. Second, it would change how we understand time. In a cyclical universe, time has no beginning and no end. It stretches infinitely in both directions. The question of what came before the Big Bang has an answer. Another universe, another cycle, reaching endlessly into the past. The question of what comes after heat-death also has an answer. Another Big Bang, another cycle, reaching endlessly into the future. Third, it would give new meaning to recurrence. In a truly infinite cyclical universe, does everything repeat? Not always in the same way each cycle. The ekpyrotic model, for example, allows different starting conditions each cycle. Each universe might be unique with its own history, its own galaxies, its own forms of life. But if the cycles are infinite and the possibilities are limited, then eventually everything must recur. Every possible arrangement of matter and energy will happen not once, but infinitely many times. You will live again, not in the next cycle maybe, but in some far future cycle, when the cosmic dice roll the same numbers that produced you here and now. This is the ultimate eternal return. Not a philosophical thought experiment, but a fact about the cosmos. If the universe cycles forever, and if the arrangements are ultimately limited, then recurrence is unavoidable. There are warnings, though. We do not know if the universe truly cycles. The evidence for cyclical cosmology is mostly theoretical, not observational. We cannot see beyond the Big Bang, cannot look into previous eons, cannot confirm the bounce really happened. We do not know if the possible arrangements are limited. Quantum mechanics brings real randomness into how the universe changes. Each cycle might be truly different, with no exact repeat ever happening. We also do not know what identity means across cycles. Even if an exact physical copy of you exists in a future universe, is that really you? Does consciousness continue across cosmic ages? Or is each copy a separate being that shares your pattern but not yourself? These are deep, maybe unanswerable questions. They push against the edge of what science can tell us and what philosophy can clarify. But here is what we can say. The universe may not be a one-time event. It may be an eternal process, breathing in and out, expanding and contracting, dying and being reborn. The Big Bang may be just one beat of a cosmic heart that has been beating forever and will keep beating forever. In such a universe, the ancient mystics and modern physicists reach the same ending. Existence cycles. Time turns. The wheel spins. And you here now reading these words may have been here before, may be here again, may be here always in a way that goes beyond our normal meaning of before and after, past and future once and again. The universe breathes, and in its breath perhaps we return. Recent observations have added the dark energy spectroscopic instrument. In 2019, suggested that data from the dark energy, the mysterious force speeding up the universe's expansion, may not be constant. It may change over time. If dark energy is changing, the universe's fate becomes unclear. It might not expand forever into cold emptiness. It might someday reverse, shrinking toward another bounce. The cycles could continue. Physicist Henry Tai at Cornell University has proposed that dark energy could come from a particle called an axion, which could naturally create cyclical behavior. The universe would expand, slow, contract, bounce, and expand again. We do not yet know if this model is right, but it shows cyclical cosmology is not a fringe idea. It is actively studied by serious scientists at major universities. It is published in peer-reviewed journals. It is part of the main conversation about the universe's ultimate fate. The question of whether life could repeat itself may have a cosmic answer. If the universe cycles, if it bounces, if it breathes, Then recurrence is built into reality itself, not as a thought experiment or a philosophical dare, but as a physical fact. The ancients looked up at turning stars and saw a cosmos moving in circles. They may have been right. The universe may be eternal, and in eternity everything returns. Chapter 6. The universe that breathes. 13.8 billion years ago, everything began. All the matter and energy in the observable universe, everything that would become galaxies and stars and planets and people, was squeezed into a state of unimaginable density and temperature. And then it exploded outward. This is the Big Bang, the standard model of cosmology, the creation story of modern science. For most of the 20th century, it seemed final. The universe had a beginning. Before that beginning, there was nothing. Not empty space, not darkness, nothing at all. But in the 21st century, this picture is being challenged. New theories suggest the Big Bang may not have been the absolute beginning, that something came before, that our universe may be just one phase in an eternal cycle of expansion and contraction. That the cosmos breathes, expanding and contracting like a cosmic lung, dying and being reborn over and over throughout eternity. This is the Big Bounce, and it may be the most powerful scientific support ever offered for the ancient cyclical worldview. The idea that the universe could be cyclical is not new. As we have seen, ancient cultures around the world imagined time moving in great circles. Hindu cosmology spoke of vast cycles lasting billions of years. The Stoics believed the cosmos sometimes returned to pure fire and then was reborn. Even Albert Einstein briefly considered an oscillating universe in the 1930s. But for decades, cyclical cosmology was considered scientifically dead. The discovery that the universe is expanding, along with the laws of thermodynamics, seemed to rule out endless cycles. The problem is entropy. The second law of thermodynamics says that in any closed system, entropy, roughly the amount of disorder, always increases. Each cycle of the universe would have more entropy than the one before. The cycles would grow longer and larger. Going backward, they would get shorter and smaller, heading toward a single beginning, a first cycle, a real creation. This argument seemed airtight. If entropy always increases, the universe cannot be truly cyclical. There must have been a beginning. But cosmologists are clever. They found ways around the entropy problem. New versions of cyclical cosmology do not require entropy to go down. Instead, they suggest ways entropy can be reset or spread out, allowing for true eternal recurrence. The most prominent of these theories is the ekpyrotic model developed by physicist Paul Steinhardt and his collaborators in the early 2000s. The name comes from the ancient Stoic idea of ekpyrosis, the periodic conflagration that consumes the world. In the ekpyrotic model, our universe is a three-dimensional membrane or brain floating in a higher dimensional space. Parallel to our brain is another brain, separated by a tiny gap. From time to time, these brains collide. The collision releases enormous energy, creating the hot, dense conditions we connect with the Big Bang. But it is not a beginning from nothing. It is a change from a previous state. After the collision, the brains separate and our universe expands. It goes through all the stages. We see atoms form, stars ignite, life evolve. Eventually, expansion slows and reverses. The brains move toward each other again. They collide. A new Big Bang happens. A new cycle begins. The key new idea of the ekpyrotic model is that each cycle includes a time of slow contraction before the bounce. During this contraction, the universe becomes smoother. Uneven parts are erased. The entropy problem is solved not by lowering entropy, but by thinning it out, spreading it over an ever larger volume so each new cycle begins in a condition that can form structure. This is cyclical cosmology for the 21st century. It keeps the insights of the Big Bang model while placing them in a bigger picture. The Big Bang is real, but it is not the beginning. It is a repeating event happening again and again forever. Another approach to cyclical cosmology comes from loop quantum gravity, an attempt to join general relativity with quantum mechanics. In loop quantum cosmology, the singularity at the center of the Big Bang is removed. Instead of a point of infinite density where physics breaks down, there is a bounce. The universe shrinks to a smallest size and then rebounds, moving smoothly from contraction to expansion. In 2006, physicist Abhay Ashtekar and his collaborators showed that loop quantum gravity naturally creates a bounce. When matter is squeezed to extreme density, quantum effects create a pushing force that prevents total collapse. The universe bounces back before reaching zero size. This matters a lot. If the Big Bang was a bounce from an earlier contraction, then something existed before. Our universe has a history stretching backward beyond what we can see, and if it bounced once, it may bounce again. The universe may be eternal, cycling through expansion and contraction with no beginning or end. Physicist Roger Penrose has proposed another cyclical model, which he calls conformal cyclic cosmology. In this picture, each cycle, or eon, begins with a big bang and ends when all matter has decayed, and the universe is made only of radiation. At this point, with no massive particles left, the ideas of time and distance lose meaning. The infinitely large, cold end of one eon becomes indistinguishable from the infinitely small, hot beginning of the next. The end of one universe is the beginning of the next universe. Infinity equals zero. The cosmic snake eats its tail. Penrose has even said he found hints of his theory in the cosmic microwave background radiation, the afterglow of the Big Bang. He argues that certain circular patterns in the radiation could be the marks of colliding black holes from a previous eon, their gravitational waves stamped on our sky as echoes from before time began. These claims are still debated. Other scientists dispute Penrose's analysis. The patterns he points to may be chance statistics rather than real signals from a previous universe. The evidence is not final, but the theoretical framework is solid. Conformal cyclic cosmology is a mathematically consistent model of an eternal cyclical universe. It may be wrong, but it cannot be ignored. What would it mean if the universe truly breathes? What would it mean if the Big Bang was not a beginning but a phase change, one of endlessly many across cosmic history? First, it would support the ancient feeling that existence moves in cycles. The Hindu yugas, the Stoic conflagrations, the Buddhist wheel of becoming. These would not be only poetic metaphors but real insights into reality. Our ancestors without telescopes or particle accelerators grasped something true about the cosmos. Second, it would change how we understand time. In a cyclical universe, time has no beginning and no end. It stretches infinitely in both directions. The question of what came before the Big Bang has an answer. Another universe, another cycle, reaching endlessly into the past. The question of what comes after heat-death has an answer too. Another Big Bang, another cycle, reaching endlessly into the future. Third, it would give new meaning to recurrence. In a truly infinite cyclical universe, does everything repeat? Not always in the same way each cycle. The ekpyrotic model, for example, allows different starting conditions each cycle. Each universe might be unique with its own history, its own galaxies, its own forms of life. But if the cycles are infinite and the possibilities are limited, then eventually everything must recur. Every possible arrangement of matter and energy will happen not once but infinitely many times. You will live again, not in the next cycle maybe, but in some far future cycle, when the cosmic dice roll the same numbers that produced you here and now. This is the ultimate eternal return. Not a philosophical thought experiment, but a cosmic fact. If the universe cycles forever, and if the arrangements are ultimately limited, then recurrence is unavoidable. There are warnings. We do not know if the universe truly cycles. The evidence for cyclical cosmology is theoretical, not observational. We cannot see beyond the Big Bang, cannot look into previous eons, cannot confirm the bounce really happened. We do not know if the possible arrangements are limited. Quantum mechanics brings real randomness into how the universe changes. Each cycle might be truly different, with no exact repeat ever happening. We also do not know what identity means across cycles. Even if an exact physical copy of you exists in a future universe, is that really you? Does consciousness continue across cosmic epochs? Or is each instantiation a separate being sharing your pattern but not your identity? These are deep questions, perhaps unanswerable questions. They push against the edge of what science can tell us and what philosophy can clarify. But here is what we can say. The universe may not be a one-time event. It may be an eternal process, breathing in and out, expanding and contracting, dying and being reborn. The Big Bang may be just one beat of a cosmic heart that has been beating forever and will keep beating forever. In such a universe, the ancient mystics and modern physicists reach the same ending. Existence cycles. Time turns. The wheel spins. And you here now, reading these words, may have been here before, may be here again, may be here always in a way that goes beyond our normal meaning of before and after, past and future once and again. The universe breathes, and in its breath, perhaps we return. Recent observations have added new parts to this picture. In 2019, Data from the Dark Energy Survey and the Dark Energy Spectroscopic Instrument suggested that dark energy, the mysterious force driving the universe's speeding expansion, may not be constant. It may be changing over time. If dark energy is changing, the universe's fate becomes unclear. It might not expand forever into cold emptiness. It might someday reverse, shrinking back toward a bounce. The cycles could continue. Physicist Henry Tye at Cornell University has proposed that dark energy could be explained by a particle called an axion, which could naturally create cyclical behavior. The universe would expand, slow, contract, bounce, and expand again. We do not yet know if this model is right, but it shows cyclical cosmology is not a fringe idea. It is actively studied by serious scientists at major universities. It is published in peer-reviewed journals. It is part of the main conversation about the universe's ultimate fate. The question of whether life could repeat itself may have a cosmic answer. If the universe cycles, if it bounces, if it breathes, then recurrence is built into reality itself, not as a thought experiment or a philosophical dare, but as a physical fact. The ancients looked up at turning stars and saw a cosmos moving in circles. They may have been right. The universe may be eternal, and in eternity everything returns. Chapter 8. The block where all moments exist. Imagine the universe as a loaf of bread. Each slice is one moment in time. The slice at one end is the Big Bang, the beginning of everything. The slice at the other end is the far future, maybe the heat death of the cosmos, when all stars have burned out and entropy is at its maximum. Between these ends are all the moments that ever existed or will ever exist. Your birth, your death, every breath you have taken, every thought you have had, every choice you have made or will make. All of them are slices in this cosmic loaf, arranged in order from past to future. Now here is the strange part. According to some ideas in physics, all these slices exist equally. The past has not disappeared. The future is not unreal. Every moment is as real as every other. The whole loaf exists complete and unchanging, a four-dimensional block of spacetime holding everything that ever happens. This is the block universe. And if it is true, then the question of whether life could repeat itself takes on a totally different meaning. The block universe comes naturally from Einstein's relativity. When Einstein joined space and time into one thing called spacetime, he showed that the difference between past, present, and future is not as basic as we feel it is. Think about the relativity of simultaneity, one of the strangest results of special relativity. According to Einstein, two events that happen at the same time for one observer may not be at the same time for another observer moving differently. There is no single universal now across the cosmos. Different observers divide spacetime into past, present, and future in different ways. This creates a puzzle. If my present includes events that are in your future, and your present includes events that are in my past, how can we say only the present exists? My present is partly your future. Your present is partly my past. If only the present is real, we get a contradiction. The block universe solves this by saying the present is not special. All moments are equally real. What we feel as time flowing from past to future is not a basic feature of reality. It is a feature of our viewpoint, our way of experiencing the block from the inside. This view is sometimes called eternalism, to set it apart from presentism, the view that only the present exists. Eternalism says past, present, and future all exist in the same way. They are all there in the block, even if we can only feel one slice at a time. Think of a book. When you read a novel, you experience the story in order, page by page, but the whole book exists at once. Page 100 is just as real as page 1, even when you are reading page 50. The characters do not stop existing when you turn the page. They are still there, fixed in the text, waiting to be read again. In the block universe, reality is like that book. We experience it in order moment by moment, but the whole story already exists. The ending is as real as the beginning. Your birth and your death exist together in the block, equally real, equally fixed. Einstein himself seems to have believed this. After the death of his close friend Michel Besso, Einstein wrote to Besso's family these striking words: "Now he has departed from this strange world a little ahead of me." That means nothing. For those of us who believe in physics, the difference between past, present, and future is only a stubbornly persistent illusion. For Einstein, death was not erasure. It was simply moving to another part of the block. Besso still existed, fixed in the moments he lived, as real as any moment in Einstein's ongoing experience. The difference between the living and the dead was only about where in the block you were looking. This is a deeply strange idea. It clashes with almost everything we naturally feel about time. We feel the past is gone and the future is open. We feel we make choices that decide what will happen. We feel time flows, that it moves, that it carries us from one moment to the next. But Einstein's physics suggests these feelings may be illusions. The block is still. Nothing moves. Change is only the difference between neighboring slices. What we feel as time flowing is a mental experience, not a physical one. Philosophers have argued about the block universe for more than a century. Some accept it as the natural reading of relativity. Others resist it, saying it clashes too much with our experience of time. The argument continues. Let us ask what the block universe means for recurrence. In one way, the block universe makes the question pointless. If all moments exist equally, then nothing repeats. Everything simply is. Your birth is not followed by your death and then by your birth again. Both your birth and your death exist at the same time as different parts of the block. There is no timeline where events could repeat. But in another way, the block universe is the strongest form of eternal existence. If every moment is equally real, then no moment ever stops existing. You are not just someone born, living for a while, and then dying. You are a four-dimensional pattern in spacetime stretching from birth to death, existing forever in the block. This is not immortality in the usual sense. You do not keep living after death, but you also do not stop existing. The moments of your life remain fixed in the block, as real as any other moments. In that sense, you are eternal. The block universe also raises questions about free will. If the future exists as firmly as the past, if every choice you will ever make is already fixed in the block, then in what way are your choices free? You feel like you are deciding, like the future is open, like things could go either way. But in the block universe, there is only one way things go. The choice is already there, written into spacetime structure. Some philosophers say this still allows a meaningful kind of free will. Your choices are still yours. They are not forced by an outside power. They come from your character, your desires, your thinking. Being part of a fixed pattern does not make them less yours. Others say the block universe destroys real freedom. If everything is set, if the future is as fixed as the past, then we are not truly choosing. We are just watching a movie of our lives, feeling the illusion of control while the story plays out from a script written before we were born. These arguments are deep and hard. They touch the most basic questions about reality and our place in it. They cannot be solved here. But consider this. If the block universe is true, then the question of whether life could repeat itself changes. It is no longer about what will happen later. It is about the shape of the block. Could the block contain multiple copies of you? Could your pattern appear again in different places in spacetime? If the universe is infinite, if the same arrangements of matter can happen many times, then maybe the block contains not one life like yours, but many spread across cosmic history. This is not repetition in the sense of one event happening after another. It is multiplication. The block holds many copies, each equally real, each existing forever. You do not live your life again. Instead, there are many versions of your life, all existing at once in reality's timeless structure. Physicist Max Tegmark has explored this idea in his Level I multiverse. If space is infinite and matter is spread out more or less randomly, then every possible arrangement of atoms will happen infinitely many times. There are infinitely many copies of Earth, infinitely many copies of you, separated by huge distances but identical in every detail. In such a universe, the block contains not just one instance of each moment, but infinitely many. Your experience right now is being copied endlessly across the infinite space. You are eternal, not because time repeats, but because the block is infinite. This is a dizzying idea. It challenges how we think about personal identity. If there are infinitely many copies of you, which one is the real you? Are they all you? Are none of them you? What does you even mean in a cosmos like this? Some philosophers say identity is not about being one and only one, but about continuing as a pattern. You are not a special pile of atoms, but a pattern those atoms make. If the same pattern happens elsewhere, that is also you in the same way that you tomorrow are you today, even though the atoms in your body constantly change. Others say identity requires causal connection. You are you because your present is caused by your past. A copy in a distant galaxy with no causal link to you is not you, but only someone exactly like you. You might be impossible to tell apart, but you are not the same person. These questions press against the limits of language and ideas. They show how much we still do not understand about what it means to be a self, to last through time, to exist at all. The block universe is not proven. It is one way to understand the physics, not the only way. Some physicists and philosophers support other views. The growing block view says the past and present are real, but the future is not yet real. The universe grows, adding new moments as time passes. This keeps some feeling of time moving, while still treating the past as fully real. Other ideas challenge the block universe using quantum mechanics. The uncertainty in quantum events may bring real openness, a future that is not yet fixed. The block would be incomplete, its future slice is not yet written. These debates continue. The nature of time remains one of the deepest unsolved problems in physics and philosophy. We do not know, and may never know, which view is right. But the block universe remains a real possibility. It matches our best physics. Many scientists and philosophers take it seriously. And if it is true, it changes what we think about existence, identity, and the meaning of our lives. In the block, you are eternal. Every moment you have lived or will live exists unchanging forever. You do not stop being, you are simply at some places in the block and not others. Is this comforting? Is it frightening? Maybe it is both, maybe it is neither. Maybe it simply is. And our feelings about it are part of the block too. The bread is baked, the loaf is complete, all the slices exist from beginning to end. And you are in there somewhere reading these words forever. Chapter 9. Patterns in the chaos. Those who cannot remember the past are condemned to repeat it. George Santayana wrote these words in 1905, and they have echoed ever since. Politicians quote them. Historians argue about them. Ordinary people feel they are true, even when they struggle to use them. But is it true? Does history really repeat itself? And if it does, what does that say about whether life itself could return? The idea that history moves in cycles is ancient. We have already seen how cultures around the world imagined cosmic time as cyclical, with great ages rising and falling forever. But the question here is different. Not whether the whole universe repeats, but whether human events, societies, dramas, and conflicts return in recognizable patterns. The Greek historian Thucydides, writing in the 5th century BCE, believed they did. He wrote his history of the Peloponnesian War not only as a record, but as a lesson for all time. He believed that because human nature stays what it is, similar events would happen again. Understanding the past would help future people handle similar problems. Thucydides saw something constant in human affairs: greed, fear, ambition, honor. These motives stay steady across ages. The details change, but the deeper forces return. Wars are fought for the same kinds of reasons. Empires rise and fall through similar ways. Leaders make the same mistakes, pushed by the same passions. The Roman historian Polybius took this further. He proposed anacyclosis, a cycle of political systems. Societies begin with monarchy, rule by one. Monarchy turns into tyranny when kings become corrupt. Tyranny is overthrown and replaced by aristocracy, rule by the best. Aristocracy turns into oligarchy when the elite chase their own interests. Oligarchy is overthrown and replaced by democracy, rule by the people. Democracy turns into mob rule when the masses become reckless. Then, out of chaos, a strong leader rises and monarchy returns. This cycle, Polybius believed, was almost unavoidable. The seeds of decay were planted at each stage. No system was stable. All societies moved through the cycle, sometimes fast, sometimes slow, but always in the same direction. We can debate whether Polybius was right about the exact order. Modern political science has complicated his simple model, but the basic feeling remains. Societies seem to go through phases. Stability gives way to disruption. Unity follows breakup. Expansion follows contraction. The 14th century Muslim historian Ibn Khaldun suggested a different cycle. He said social cohesion, group solidarity, was the key to dynasties rising and falling. Nomadic peoples in harsh conditions develop stronger asabiya. They must rely on each other. This unity lets them conquer settled peoples whose asabiya has weakened through luxury and ease. But once the conquerors settle, once they become civilized too, their asabiya fades in a few generations. They grow soft and vulnerable. A new group with stronger unity rises and defeats them. The cycle continues. Ibn Khaldun estimated dynasties usually last about 4 generations, around 120 years. The pattern is not exact, but it gives a rough way to understand political change. In the 20th century, the British historian Arnold Toynbee tried to write the most ambitious cyclical history ever attempted. His 12-volume A Study of History looked at the rise and fall of 21 major civilizations, searching for shared patterns. Toynbee described a rhythm of challenge and response. Civilizations rise when a creative minority answers hard challenges well. They grow as long as they keep inventing new solutions. But eventually, the creative minority becomes a dominant minority, more focused on keeping power than on creating. The masses become alienated. The civilization enters a time of troubles, wars, and crisis. A universal state appears, bringing temporary peace, but the civilization is already dying. It is replaced by successor civilizations that go through their own cycles. Toynbee's work was controversial. Critics said he picked evidence to fit his story, that his categories were too vague, that his comparisons were shallow. But his central insight stuck. Civilizations do seem to follow patterns. They rise, flourish, decline, and fall. The causes vary, but the overall shape repeats. More recently, historians William Strauss and Neil Howe suggested generational cycles in American history. They argued that about every 80 years, roughly a long human life, America faces a major crisis that reshapes society. The American Revolution, the Civil War, the Great Depression, and World War II each happened about 80 years after the last. They say we are now in another crisis, a fourth turning. The old order is breaking, a new order is struggling to be born. If the pattern holds, they say we will come out of this crisis around 2030 with a changed society. The theory is speculative. History does not have to follow any pattern. But Strauss and Howe pointed to something real about generations. People shaped by the same big events often share similar outlooks. Generations move through life stages. Values formed in youth often last into old age. This creates rhythms in social and political life. What does this mean for whether life could repeat itself? On one level, historical recurrence is clearly different from cosmic recurrence. When we say history repeats, we usually mean similar patterns happen, not the exact same events. The French Revolution was not the same as the English Civil War, but they shared features. The 2008 financial crisis was not the same as the crash of 1929, but the deeper forces were similar. This is recurrence of types, not tokens. The same kind of thing happens again, not the same exact thing. It is pattern recognition, not literal repetition. But noticing patterns raises deeper questions. The number of possible outcomes may be limited, so societies may eventually cycle back to earlier states. Niccolò Machiavelli, the Renaissance political thinker, believed human nature was the key. Writing in the early 1500s, he argued that because human nature does not change, the same kinds of events return. The passions that drove the Romans drive us. The mistakes the Greeks made, we make. History teaches because people stay basically the same. If Machiavelli is right, then history repeating is unavoidable. As long as humans are human, the same dramas will play out. Wars for the same reasons, empires rising the same ways, leaders falling into the same temptations. But is human nature really that fixed? Modern psychology and anthropology stress how much behavior changes across cultures and time. What counts as normal, acceptable, even possible, has changed greatly. Ancient Romans were not psychologically identical to us. They had different assumptions, different values, different ways to make sense of the world. Maybe patterns repeat not because people never change, but because societies face similar limits. Societies must solve certain problems: how to produce goods, how to share resources, how to keep order. The range of solutions is limited. That could create similar results, not because of psychology, but because of necessity. Or maybe some patterns are partly in our heads. Humans are pattern seekers. We look at history's chaos and try to make it orderly. We see cycles because we expect them. We find parallels because we hunt for parallels. Some patterns may be in our minds as much as in the record. There is a warning here. People have often tried to use supposed historical patterns to predict the future. They usually fail. The future does not simply copy the past. It brings real novelty, new technologies, new ideas, new possibilities with no earlier match. Think how much the last century changed. Nuclear weapons, computers, genetic engineering, global communication. These changed human life in ways with no clear earlier parallel. Old patterns might stop fitting. We might be in truly new territory. And yet the old patterns still seem to return. Political polarization, economic inequality, nationalist movements, religious revivals. These echo earlier times, even while shaped by new conditions. Maybe human societies, like living things, have characteristic dynamics that persist even as environments change. The question stays open. Does history repeat? If it does, is that because repetition is built into reality, or because we keep making the same mistakes until we learn? Mark Twain is often said to have remarked that history does not repeat, but it often rhymes. That captures something important. The patterns are not exact repeats. They are variations on themes. The same melody in different keys at different tempos with different instruments. Maybe that is the deepest truth about recurrence in human life. Life does not repeat exactly, but it echoes. It resonates. It returns to the same themes, the same struggles, the same questions, generation after generation. We are not trapped to repeat the past, but we are linked to it. The patterns that shaped our ancestors shape us too. Their challenges return to us in new forms. Their choices appear again in our choices. In that sense, history repeats, not as a perfect loop, but as a long conversation across time. A story retold with new characters playing familiar roles. And in that story, perhaps we glimpse something eternal, not cosmic recurrence, but human recurrence. The same dramas acted on the same stage by creatures who love and fear and hope and suffer as they always have. The wheel turns, the patterns persist, and we, swept along by history, play our parts in a story that is both ancient and new. You have been here before. Not you exactly, but someone like you, facing problems like yours, making choices like yours. And someone like you will be here again. Chapter 10. The answer that changes everything. We have traveled far from the ancient temples of India where priests first imagined time as a great wheel, through the Swiss Alps where Nietzsche had his terrifying vision, into the patent office in Bern where Einstein changed how we understand space and time, to the edges of black holes where time bends and stretches, through the strange loops of wormholes and closed time-like curves, into the breathing cosmos of big bounce cosmology, through the misfiring synapses of déjà vu, across the frozen expanse of the block universe, and along the winding paths of human history where patterns return generation after generation. Now we must ask the question we have circled all along: could life repeat itself? The honest answer is, we do not know. The deepest mysteries are still mysteries, but we have learned enough to say something meaningful, something that might change how you think about being alive. Let us look at the possibilities. If Nietzsche's eternal recurrence is literally true, if the universe is finite, time is infinite, and identical arrangements must happen, then yes, life repeats. You have lived this moment before infinitely many times. You will live it again infinitely many times. Every joy, every sorrow, every choice, every breath, forever. This is the most extreme form of recurrence. It has not been proven. Modern physics does not clearly support it, but it cannot be fully ruled out either. The universe may be built in ways we do not yet understand. Eternal return may be waiting at the end of physics, the conclusion we reach when all equations are solved. If Big Bounce cosmology is right, if the universe cycles through expansion and contraction forever, then recurrence looks different. Each cycle may be unique with its own history, its own galaxies and stars and planets. But if the cycles are infinite and the possibilities are limited, then eventually everything returns. Not necessarily in the next cycle, but somewhere in the endless sequence, a universe appears that contains you living this life, reading these words. This is statistical recurrence. Given enough time and enough repetition, any possible event becomes unavoidable. Monkeys typing Shakespeare, given infinite time, eventually type the complete works. A universe cycling forever eventually produces you again. If the block universe is true, if past, present, and future all exist equally in a four-dimensional spacetime block, then the question of recurrence changes. Nothing repeats because nothing happens only once. Everything is. Your birth and your death, your first love and your last breath all exist forever in the block. You are not someone who was and will be. You are a pattern that exists timelessly. This is eternal existence without recurrence. The wheel does not turn because there is no turning. The block simply is, complete and unchanging. In one sense, nothing repeats. In another sense, everything is already there. If space is infinite and matter is spread randomly, then somewhere unimaginably far away, exact copies of you exist right now. Not in the past or future, but in the present. Separated by billions of light years, living lives identical to yours. This is not recurrence in time, but multiplication in space. Infinite copies, each equally real, each living what seems like a unique life, but is actually one instance among infinitely many. This is parallel existence. The question, will you live again, becomes, is the other you really you? Does identity stretch across space when no causal connection is possible? Or are you and your duplicate separate selves sharing a pattern but not a mind? And even if none of these cosmic possibilities happens, there is still historical recurrence. Patterns that shaped past generations shape us. Challenges our ancestors faced return in new forms. Human nature, human society, or both seem to create recurring dynamics. Wars and revolutions, rises and falls, the return of the same struggles and hopes. This is recurrence of types, not tokens. Not you exactly, but someone like you facing situations like yours, making choices like yours. The wheel turns and the drama continues, with new actors playing old roles. So does life repeat itself? In the cosmic sense, we do not know. Physics is incomplete. Evidence is unclear. We cannot say for sure whether the universe cycles, whether the block is real, whether infinite copies exist. In the human sense, something like recurrence seems hard to deny. Patterns persist. History rhymes. The same struggles return in new shapes. We are linked to the past and future in ways that reach beyond one lifetime. But maybe the question was wrong from the start. Maybe the important thing is not whether life literally repeats, but what it would mean if it did. This is Nietzsche's insight. Eternal return is a test, a thought experiment, a way to measure how you relate to your own life. Ask yourself, if you had to live this exact life again, would you accept it? Would you say yes to every moment, including pain, failure, and loss? Would you love your life enough to will its eternal return? If you would, you have done something rare. You have said yes to existence without holding back. You have affirmed life fully without a secret wish that things had been different. This is amor fati, love of fate. It is the highest form of affirming life. If you would not, then you have work to do, not to change the past, you cannot, but to change how you meet it. To stop wishing things were different, to accept what is, to find meaning not in imagined alternatives, but in the life you truly have. This is the practical lesson of eternal recurrence. It is not a prediction, but a way to live. Live as if everything returns. Choose as if your choices were eternal. Make every moment worthy of repeating. There is another lesson too. Studying recurrence shows how strange reality is. Time is not what we think. Consciousness is not what we assume. The difference between past, present, and future may be an illusion. The self may reach farther than we imagine, either into eternity or across infinite copies in space. We are small, temporary creatures on a tiny planet, or rather, we are that, but we are also more. We are patterns in spacetime, arrangements of matter and energy with meaning beyond a single moment. We are linked to the past and the future, to distant galaxies and possible cycles of the cosmos. We are part of something vast and strange and wonderful. This does not answer every question. It does not solve every problem. Pain still hurts. Loss still grieves. Death still comes. But it changes the frame. It shows that even the smallest life is woven into something immense. You have been here before, maybe literally, maybe as a metaphor, maybe in a way we cannot yet describe. The patterns that make you have existed for billions of years and will exist for billions more. The atoms in your body were forged in dying stars. The thoughts in your mind are ripples in a vast sea of consciousness spread across time and space. You will be here again, maybe in a repeating universe, maybe in infinite copies across space, maybe in the eternal block where all moments coexist, or maybe only in the sense that others will come after you, facing similar challenges, making similar choices, carrying on the human story. The question is not whether life repeats. The question is what you will do with the life you have, how you will face the challenges ahead, what meaning you will create with the time you are given. The ancients who watched the turning stars and saw cycles in the cosmos were touching something true. The philosophers who offered eternal recurrence were saying something important. The scientists who found time dilation and the block universe uncovered realities that change how we understand existence. We stand where these insights meet. We know more than any earlier generation about time, space, and matter. We have more tools to think about these questions. And we face the same basic challenge every conscious being has faced. To make sense of existence, to find meaning in mystery, to live well in a universe we do not fully understand. The question that haunts humanity has no final answer. But by exploring it, we have learned something valuable. We have seen how deep the question goes, how many areas it touches, how many possible answers remain open. We have learned that time is stranger than we thought, that identity is more complex than we assumed, that existence may be richer and more enduring than we dared hope. And we have learned the question itself is a gift. It forces us to think about what matters. It pushes us to be clear about our values. It invites us to take life seriously, to treat each moment as potentially eternal. Could life repeat itself? Perhaps in ways we cannot yet imagine. But one thing is certain, this moment right now is real. This choice you are making, to pay attention, to think, to engage, belongs to you. Whatever comes before or after, whatever the structure of spacetime turns out to be, you are here now. And that is a kind of miracle. The wheel may or may not turn, the universe may or may not cycle, the block may or may not hold all moments forever. But you exist. You think, you feel, you wonder. And in that wondering, you take part in something ancient and ongoing. The human search to understand, the search for meaning in mystery, the attempt to live well in a cosmos that remains, despite our efforts, ultimately unknown. The question haunts us. It always has. It always will. And by being haunted by it, we become more fully human. Thank you for joining me on this journey. If you have found value in this exploration, please like this video and subscribe to the channel. Your support makes these deep investigations possible. Let me know in the comments what you think. Does life repeat itself? Would you want it to? What would you do differently if you knew you would live this moment again? These are not idle questions. They are invitations to think more deeply, to live more fully, to face the mystery of existence with courage and curiosity. The wheel turns, or it does not. Either way, you are here, and that is enough. Until next time, keep wondering, keep questioning, stay awake to the strangeness and beauty of this cosmos we call home. You have been here before. Perhaps you will be here again. For now, you are here. That is everything.